So hi guys, here let's discuss a problem on total energy line and the hydraulic gradient line. So we have discussed the theory part in earlier chapter, earlier lecture. So here we'll discuss a sample problem. So as I said, it's a graphical representation to find the amount of energy present at any given point of a pipeline. If we want to find at this length of pipe, so we draw a vertical line. So from x to y, so we can find what is the amount of energy present at. Okay, right. So the sample problem which I have taken from a textbook. So already we have discussed the same problem on a losses through pipes. Losses in pipes. So we have derived this problem, solved it, and we have found what is a rate of flow, right? So here for the same problem we're going to find the head loss, total energy line and hydraulic gradient line. So the problem defines a horizontal pipeline 40 meter long is connected to a water tank. So this length of the pipe is 40 meter long, connected to the water tank at one end and discharges freely into the atmosphere at the other end. For the first 25 meter of its length from the tank, the pipe is 150 diameter, so 150 mm in diameter, and its diameter is suddenly enlarged to 300 mm. So first 25 mm, the diameter is 150 and suddenly enlarged to 300 mm for the rest of the length. The height of a water level in the tank is 8 meter above the center of the pipe. So this is the center of the pipe. From center of the pipe, the water level is 8 meter. Considering all the losses which occurs, determine the rate of flow. So we have already solved this problem and have found the rate of flow. Okay, so we know to find the rate of flow we need to know the velocities, right? So v1 and v2 we have found. So v1 will be equal to, right, so v2 is known. So v2 will be equal to 1.13 meter per second. Then v1 will be equal to 4 times of v2. Okay, so 4 times of this value will be nearly 4 point something, right? So v1 v2 if known, then probably substitute all this v1 v2 to find the various head losses. First we need to find various head losses. Okay, so what are the head losses which occurs? So from this pipe we know, from the tank to the pipe we will have head loss due to inlet. Then for the length of this pipe we'll have the head loss due to friction. From there we'll have head loss due to sudden expansion. Okay, so from 150 to 300 mm diameter there will be sudden expansion, so there will be head loss due to sudden expansion of pipe. Then the fluid flows on the second pipe, so on this length of a pipe we'll have again head loss due to friction. From pipe we will have a exit. Okay, so this will be the total head losses that is been present in this pipe flow. So first we're going to find head loss due to inlet. So 0.5 v1 square by 2g. v1 we have already known, 4 v2, so v2 we have already calculated here. So v2 1.13 meter per second, so v1 will be 4 times of v2, so 4.452 meter per second. So v1 v2 known, so substituting these values in the different head losses you can find. So hi will be 0.50 meter. hf1 is a head loss due to friction in pipe 1, so on this pipe 1. 4f L1 v1 square by 2 d1, so substituting this we get 6.73 meters. So second, from then we have a sudden expansion, so He will be equal to v1 minus v2 square by 2g. So v1 v2 known, so simplifying we get 0.568 meter. Then from a sudden expansion we have friction losses in a length of pipe 2 for 15 meter. Okay, so this will be hf2 will be equal to 4 of L2 v2 square by 2g d2. So substituting these values we'll get 0.126 meter. Then head loss at outlet will be equal to v2 square by 2g. So from here the water tends to flow out. Okay, so it will be equal to 0.063 meters. So also v1 square by 2g is a kinetic head in pipe 1. So this pipe, what is a kinetic head? So this will be kinetic head at 2. We have already known these values, 1 meter and 0.063 meters. So first what we're going to do is we're going to draw the total energy line, because we know the total energy line is the summation of pressure head, kinetic head and rate of head. We discussed in the theory part. To draw the hydraulic gradient line will be equal to total energy line minus kinetic head, or hydraulic gradient line will be equal to summation of pressure head plus rate of head. Okay, so first we're going to draw the total energy line. So the total energy is present in the given given sample is 8 meters. So which is a potential head which is actually present in this fluid flow. So 8 meter. So this will be point A will be the free surface of water. So this will be the amount of energy that is present. From here we are going to draw. What happens at this point? We'll have an energy loss due to inlet. So what is the energy loss due to inlet? So we have found which is equal to 0.5 meter. So from here we're going to draw minus 0.5 meter, because from here we have some energy losses. Okay, so at this point actually total energy is 8 meter. So when the fluid enters into the pipe, so due to inlet there is some losses which is 0.5 meter. So from here 0.5 meter we're going to draw. Then throughout this pipe length we have a head loss due to friction. So this head loss due to friction is been found out, which is equal to 6.73 meter. So from B, measure 6.73 meter till the end of the pipe 1. So we're going to mark the point C. So connect BC will have a slope. Okay, so this will be the amount of energy that is been present at point C. So at this point what will be energy present will be 8 minus 6.73 minus 0.5. So this will be the amount of energy at present at this level. What happens again? So the from pipe C, at this point the pipe suddenly enlarges. Okay, so we have expansion, sudden loss due to expansion, so which we already found, which is equal to 0.568 meter. So from point C, so it is happening at this point exactly, right? So from point C minus 0.568, so if you minus, so you will get point D. Okay, so then what happens? From this pipe 2 we will have again head loss due to friction. So on pipe 2, so we have found which is equal to 0.126 meter. From D measure 0.126 meter. From D measure 0.126 meter and mark a point at the exit of the pipe. So till the end of the pipe. Okay, so this will be the end of the pipe. So connect point D and E. Okay, so this will be the head loss due to friction in pipe 2. So at this point, okay, at exit of pipe, so we will have energy loss which is equal to 0.063 meter. So from here actually the end value will be equal to 0.063 meter, 0.063. Okay, so what happens? The total energy whatever been present 8 meter will be equal to, if you sum the all values, will be equal to 8 meter actually. Okay, so that's how it is been used. Hope you guys got an idea about the total energy line. So this is used to find what are the amount of what is the amount of energy present at any given point. So for example this length is 25 meters. So if you want to find the amount of energy present at 20th meter, so you take a scale, keep it vertical, okay, mark a point and take a scale, move it to the horizontal. So this will be the scale reading from 0 to 8 meter. So we'll be able to find what are the point coincidence, maybe 6.5 or maybe 6.8. Okay, so that will be the amount of energy present at that particular point of a particular length of a pipe. Okay, right. So now we're going to find what is the hydraulic gradient line. So we know that hydraulic gradient line will be equal to the total energy line minus kinetic head. So kinetic head in pipe 1 we know, which is 1 meter. Kinetic head in pipe 2 will be equal to 0.063 meter. So kinetic head will be V square by 2G. So V2 square by 2G for pipe 2, V1 square by 2G for pipe 1. So 1 meter and 0.063 meter. So what you're going to do is from B measure 1 meter, mark a point G. Okay, so actually we'll go in a reverse way. So this will be the forward way. From here it will go in a reverse order. Okay, so what happens, this length we know, which is equal to 0.063 meter. So from here 0.63 meters, so it will be the center axis of a pipe. Okay, so draw a line which is parallel to DE. Okay, so draw a line which is parallel to DE. So that will be E and H, EF, H. Okay, so from F we draw a horizontal line, for DE we will draw a line. Then what happens, from B to G it will be 1 meter. So from B to G draw a 1 meter line. Then draw G to H, is a parallel line, a line parallel to BC. Okay, because at any point the difference should be 1 meter. At any point the distance should be 0.063 meters. So if you draw, then you will get H. So join H and this point you will get EFGH. So this will be the hydraulic gradient line. So hope you guys have got some idea about the hydraulic gradient line and energy gradient line. So there are a few points to explain you clearly. So you can go through the textbook, you will find these points. So how to draw them. So I have given you the brief idea about how to draw the total energy line and how to draw the hydraulic gradient line. This hydraulic gradient line defines you the amount of energy which is present at any particular point without considering the kinetic head. Okay, so thank you guys for watching this video. Hope you got some idea. Thank you.